the chain rule. Okay, let's explain it through something simple. Consider y equals 6x minus 10. We know that y prime would equal what in that situation?
Oh, we're supposed to start time?
What's the derivative? No.
6.
Thank you. It should be 6. Because if I kind of do that chain rule here, and this is a 1, 1 times 6 is 6, that goes to 0, and any constant goes to 0. So we get 6. So now, what happens if we factor y? And y becomes 2 times 3x minus 5. What would happen? We're not multiplying things, right? We're not multiplying things, right? So, we have two functions. We have two functions, 2 and 3x minus 5. Okay? Let's now say that y equals 2u. Let's just throw in u. Okay. Where u equals 3x minus 5. Okay? So basically we're going to use substitution. We're going to throw in a u for 3x minus 5 so it becomes easier. So now, alright, so now the chain rule says, alright, that dy dx, which is the overall derivative of y, that's the nth derivative we're looking for, is equal to the derivative of y with u, okay, and the derivative of u separately, okay, times by the derivative of u separately. So, it's kind of like f of g of x. Remember how you had that thing back in the day where you take one function and put it into the other and expand it? It's kind of similar. So, we now want to find the overall derivative of y by taking the derivative of y with u and multiplying it by the derivative of just u. Alright, so let's take a look at this. The derivative of y with u is this right here. The derivative of 2u would just be, if I were to treat u like a regular variable, that would just be 2, wouldn't it? Times the derivative of whatever u is. What's the derivative of 3x minus 5? That's it. So I take the derivative of the one item I have, this right here, and then I multiply it by the derivative of the item I replaced the u with.
2, 3.
Let's rephrase what we have here. Y was equal to 2 times 3x minus 5, right? I want to say, well, let's make u equal to 3x minus 5. So now this is just basically 2u, right? So now what's the derivative of this? If u is a regular variable, that's just 2, isn't it? Times, we've got to multiply by whatever we took out and put the u in for, the derivative. So what's the derivative of this now? There we go. Okay, now that was a simplistic example. Let's apply it to something that's more relevant to it. Okay? An object moves along the x-axis, so that's position at any time where t for time is greater than or equal to 0. It's given by this function x of t. Okay? And it equals cosine of t squared plus 1. Now find the velocity of the object as a function of time. They don't want to know the velocity at a certain given of time, a certain given point in time, They just want to know what's the equation for the velocity. So I need to take the derivative of position, don't I? Acceleration would be the derivative of velocity, actually. they just want to know, find the velocity as a function of time. Function is an equation with respect to t. So I want to find an equation that uses t as a variable that gives me velocity. Okay? So guess what? I got to take the derivative of this. What would you tell me the derivative of cosine is? If you get to the c, it's negative, remember? Remember our tricks? Negative sign, you're right. So, if it begins with a c, it's always the negative derivative. The derivative of cosine is negative, the derivative of cosecant is negative, and the derivative of cotangent will be negative. So if it begins with a c, when you take the derivative of it, you got to negate it. Okay? So this will be negative sine, but I can't, this is wrong if I just leave it like this. That is not right. You want to know why? Let's bring this over here and do the chain. I'm going to say, I'm going to take the cosine of u, where u is t squared plus 1. Follow? I'm just going to replace t squared plus 1 and replace it with a u, which is what I did. Now the derivative, if that was just cosine of x, that would just be negative sine of x, or in this case, u, wouldn't it? But don't forget, my chain rule tells me, not only do I need to take that derivative, I also got to multiply it by the derivative of whatever u is. That's what this is. We can also call that u prime, right? So, what's the derivative of u here? 2t. So I got to multiply this whole thing times 2t. So when I rewrite it nice and neat, I put negative 2t. I put that out front. Sine, and I'm not going to write u again. I'm going to replace that with the original expression. What goes back in for u? Yeah. So let's recap this, okay? We took the expression t squared plus 1 and turned it into a u. We said let u equal t squared plus 1, and we did right here. When we take the derivative of this, it's just the negative sine of u. But I need to take this derivative and multiply it times the derivative of whatever u was right here. And we say that's 2t, so we multiply it times 2t. So when we rewrite it, we say the negation of 2t times the sine, and now, and this is our final answer, we are going to take our u and put our expression back in for it, which was t squared plus 1. Now, Irving, you noticed something easier we could do. That was, and this is when you get good at this, you don't have to write the u or whatever. You take the derivative of this whole thing. Well, I guess we'll start with cosine. We don't want the acceleration yet. Okay? I take the derivative of this. Well, it's negative sine times t squared plus 1, and multiply it times the derivative of what's in there, which is 2t. And when I rewrite it, I put my negative 2t up front times the sine of t squared plus 1. And that's your answer. It's the same thing we got right here. Some people like to write the u out and do it all nice and organized, and some people can do it on the fly. The more comfortable you get with it, the more you'll get this way on the left. All right, so we're going to differentiate this. So first off, what's the derivative of sine? That would be cosine of x squared plus x times what? Times 2x plus 1. Because the derivative of this is 2x plus 1. And when I write it all out, I put, my trig normally comes second if I have a constant or variable. So I write 2x plus 1 times the cosine of x squared plus x. And there you go. It's not that crazy. Okay, repeating the chain rule. So instead of doing the chain rule once, we're actually going to do it multiple times, in this case twice. So let's start out like we normally would. Okay, I'm going to just take the tan of derivative, or excuse me, the derivative of tangent, which is what? It's secant squared. So I have secant squared of 5 minus sine of 2t. Now I need to multiply by the derivative of this. Okay? The derivative of that 5 minus the sine of 2t. What is that? So times, what was it? The 5 goes to 0, right? So 0, and what would this be? Yeah, minus cos of 2t, okay? But now what else do I have to do? Yes, but that's a minus, so it's 0 minus cosine, so it wouldn't wipe out to be 0. And now what do we do? Now we got to take times the derivative of this. It would, well, what's the derivative of 2t? 2. Okay. Right, that's what she said. So, we're going to write this all out together. We put our constants out front. 2 times the secant squared of 5 minus the sine of 2t times, so that negative come out front. I'm going to get tricky. Instead of saying times the negative cosine of 2t, I'm going to say this negative 1 I'm going to bring up front, out there, okay? Cos of 2t. And that is your answer. So, let's go over this one more time. I'm going to write it a different way. Yes?
We're going to make that first thing, parentheses -2.
What first thing?
The first parentheses and that also makes
No, because when I multiply everything together, like if I have a positive 8 and then times a positive 3 times a negative 4, I mean ultimately it's the one negative. It's like saying negative 8 times 3 times 4. So the way this will negate both of these. This one. What's that, Irving? Because this is the derivative of this. Because once I get this derivative, there's 2 more functions here. Thank you. 2t was one of the original functions. I can't just leave that alone. I gotta, do the thing about it. So, let's do this another way. Let's try this in a more organized way, okay? So I need to take the tangent. We started out, I'm going to write it this way. Maybe it'll look a little bit more easier to the eye. The tangent of 5 minus sine of 2t, okay? So I know that's secant squared times 5 minus the sine of 2t, all right? I got to multiply this by the derivative of 5 minus the sine of 2t, right? Okay? Now when I take that derivative, what do I get? Right. So this is going to be replaced by the 0 minus cos of 2t. But when I take this derivative, it's the derivative of this, which is here, times the derivative of this. That's where that 2t comes at the end. And the 2, you see what I'm saying? Does that make more sense when I kind of patiently break it down that way? So that's why that 2t breaks off separately. Because when you take the derivative of a function, which needs to be split again, I think so. I mean, you can do u and b. You can do like 2 letters that way. In fact, that's the way some people teach it. But as long as you know the chain rule, take the derivative plus the derivative of the function. Boom, here's the derivative. I got to take the derivative and then the derivative of the function attached to it again. Then once you do that, you don't got to do it a third, step in this case. So, you got to do it this way? Yeah. That's what a lot of people do. Yes, it's a reference to the movie. All right. Now that's another video. All right. Finding dy dx parametrically. Okay. Find the line tangent to the right-hand hyperbola branch defined parametrically by x equals secant of tangent and y equals tangent. Okay, excuse me. X would equal secant of t, and y would equal tangent of t. All right? From this range where t is negative 90 degrees to positive 90 degrees, or we call it negative pi over 2 to positive pi over 2. At the point, radical 2, 1. Oh my goodness. Where t equals pi over 4. So what we need to do, in order to use our equation, they want to find the line tangent, okay? Which means y minus y1 equals m times x minus x1, okay? We have an x and a y already, right here. We have an x and a y already. We have an x and a y. All we need, we have an x and we have a y. The only thing we need is our slope, right? Isn't slope the derivative? I need the slope right at sine pi over 4. Okay? Now, when they say parametrically, basically, all that is this. The derivative, dy dx, is the same as taking the derivative of y over the derivative of x. So, I mean, take a look at this. Take a look at the way this is set up right here. If I had this fraction to the right, and I told you to simplify it, can I multiply the top and bottom by dt? And what happens? I have dy over dx, don't I? With respect to time. You don't have to worry about it because guess what? It wipes away. You can take the derivative of your y over the derivative of your x. So whenever they give you parametrically and they give you an x and a y function, the derivative of y with the derivative of x. Isn't slope y over x? Derivative of y with derivative of x. That's what it looks like. So now, you ready for this? My dy dx, which is ultimately my slope, that's the derivative of tangent, which is what? Okay, well, y is tan. What's the derivative of tan? Secant squared. That's okay. All over, my x is secant. So what is the derivative of secant? Secant times tangent. So all I got to do is kind of simplify this out, and then plug in my pi over 4 for t, which I leave out until I get to the end here. Technically, there should be a t here, and a t here. Well, let's simplify that. What can I simplify in that fraction? Yeah, one secant here will cross out with one of these. So now, I'm left with the secant of t over the tan of t. This actually simplifies nice. Okay, what is secant equal to? Not the derivative, what is secant equal to? 1 over what? 1 over cosine, isn't it? What is tangent equal to? Sine over cosine. Which means, what can I do here to that fraction? I can make the cosines go away. If I multiply the top and bottom by cosine, the cosines go away, don't they? Which is 1 over sine, which is what? Yes, it's cosecant. So the cosecant of t, that's my slope, where t is pi over 4. So they want the cosecant of pi over 4. That's basically 45 degrees, people. And if I know the value of the sine of 45 degrees, how am I going to know what the cosecant of 45 degrees is? It's just a reciprocal, right? They're just split with each other. Watch everybody. 45, 90. Isn't it 1 radical 2? Okay. Sine is opposite over hypotenuse. That means cosecant should be hypotenuse, because it's the reciprocal of sine, isn't it? It's the reciprocal of sine, isn't it?
Yes.
Yes? Bear with me. We'll re-explain. Opposite, hypotenuse, adjacent. Cosine is adjacent. Cosecant is the flip of sine. Isn't secant the flip of cosine? So cosecant is the flip of sine. So whatever sine is, opposite over hypotenuse, cosecant. Yeah, I'm saying sine. Okay, you with me now? You with me all right? Question. All right, so now we know that it is radical 2 over 1, which is radical 2. It's about to right, but guess what? That's your slope. Your slope is radical 2. Just to find the slope. But guess what? You have an x, you have a y, and now you have a slope. So y minus y1, which is y, equals radical 2 times x minus